Hello everyone. Today we are going to see some SUID examples. Now what is SUID? Well, SUID is set user ID. They are special permissions for a file in the Linux systems. So suppose there is SUID bit set for a binary. It means any user can execute this binary as an owner of this file. So there are some files. There is already SUID bit set for those files. I am giving you an example. Suppose this is a file passwd. You can see this S character. It means SUID bit set as an owner. So any user can execute this file as an owner, and owner of this file is root. That's why you can execute this file as a root, and that's why you are able to change your password. But there are some special conditions are written inside this binary. That's why you cannot change the permission of other users. So any binary which has SUID set, it means you can run the binary as an owner of the file. Now you might have a question, if suppose any shell script there is SUID bit set, so can you run shell file as an owner of the file? Well, actually, because of the security concern, this feature is disabled in almost all of the Unix systems. So now you cannot run a Linux shell script as an owner of the file if SUID bit is already set for that file. Now I'm showing you some examples of SUID bit. Okay, this is a whoami C code of this command. So when any user run this command, it means it returns the name of the user who is logged in. Suppose root is going to run this command, it means it returns the user root because root is logged in. I am making binary of this code. So in this folder you can see I have already put this file here. This is the code of whoami. Now I am going to create compiled file of the C code, and its compiled file name is whoami. You can see this binary is created and its owner is root. So if root is executing this binary, it returns the user root. But suppose any other user, I am logged in as an other user, and if other user executes this binary, it returns the logged in user, that is not root. Now suppose I set SUID bit for this binary. So currently write permission for only for roots, that's why only owner can set the SUID bit for this binary. So you can also use +s, but I am using 4755. 4 is for this binary SUID bit, that is for owner. Now you can see this is the binary, and here SUID bit is set. Now if root is going to run this file, it returns the root because root is logged in here, but here different user is logged in. And now if this user run this binary, it still returns the root because SUID is bit set for this binary, and it runs this binary as an owner, that is root. So that's why it returns root. Now suppose I have a shell script whoami.sh. and inside it I am going to run this command whoami. I am using the interpreter, that is bin.sh. It is my interpreter. Now if root runs this shell script, it returns the user root. But suppose any other user, if he runs the shell script, it returns the logged in username. If I set SUID bit for this shell script also, Now if root runs this file, still it returns the user root because root is logged in here. Now any other user is running this file, still it is returning the user logged in username. It is not returning the root because SUID bit, it does not work for shell scripts. There are some security concerns, that's why it does not work. So what are those security concerns? Suppose this shell script, it removes the file which is passed as a positional parameter. If root runs this file and delete a file here which is inside TMP. So suppose this script removes this file, but if SUID bit is set for it, so whoever is going to run this file is running as an owner, that is root. So other user can remove the sensitive files like etc shadow, that is password file, or etc passwd or group file. So any user can remove it because the shell script is removing these passed positional parameter files. Another example is malicious interpreter. I'm going to give you example. Now this is one file which only runs as a root because owner is root, and nobody can update this file because write permission is only for root. So inside this file you can see this parameter, this interpreter is set, but this can be changed easily. Suppose I have written my own interpreter and it is a malicious one. Suppose that is inside bin bash. Suppose this is one malicious interpreter which I have written. So if I have used like run the file like this, it does not use this interpreter, it will use this interpreter. And why? I am going to show you. I am going to update this file. And here I am using this code. This code returns the interpreter which is shell script is using. So if I run now, it is returning the interpreter bin sh because this is the interpreter I am using. But suppose if I run like this, bin bash and whoami.sh, now it returns the interpreter, this one, because I have used this one. So interpreter can be changed easily and any malicious interpreter can be used. Another example is I can easily change the binaries. Suppose in the shell script I am using listing a file of a folder etc. I am listing this file as a root user because root has permission to list any folder, so root can list it. But what can I do? I can change because I have not given absolute path of ls, so I can point ls to anywhere. I have copied this file. The rm file is copied as an ls. So export path is equal to /tmp, then path. Now if I search which ls, it will showing me temp ls. This is my ls. Suppose I have written this ls. So this could be really dangerous. If there are some bugs in the script that can be exploited by other users and they can run that script as a root. And another issue is race condition. Race condition are less likely in binaries because the binary is loaded and executed directly by the kernel. But because scripts are interpreted, there is a brief period where an attacker might exploit the time between when the script is invoked and when it is interpreted to modify files or the environment. So this is another reason SUID bit cannot be used for shell scripts. I hope this tutorial will help you. Thank you for watching.